I'm here today to talk to you about continuous deployment, its benefits, its challenges, and its relevance to the enterprise. I'm going to start by defining what continuous deployment actually is and what it isn't. We're going to talk about continuous integration and continuous delivery and how the three things relate to each other. We're going to talk about some of the challenges that you're going to face along the way if you choose to implement it. We're going to talk about some of the differences between enterprises and startups and the challenges that, or the additional challenges, I should say, that an enterprise is likely to face over a startup, and also some of the extra tools in our arsenal in the enterprise world that startups don't have. And then finally, I'll tell you a cautionary tale from the early days of our Agile journey. So, there are three very similar sounding terms which you should already be familiar with: continuous integration, continuous delivery, and continuous deployment. As I said, I'm going to start by defining continuous deployment, and then we'll put it in context. So, continuous deployment is an automated release process where every build is deployed into production with no human intervention. This is true as far as it goes, but I think we can all agree that as that stands, that sounds pretty scary. It's lacking controls, right? The basic control that we should have is that all the automated tests have passed before that release gets pushed into your production environment. And if you Google continuous deployment, this is pretty much the definition that you're going to find. Personally, I don't think it actually goes far enough. I don't think it's good enough to simply say that the code itself has passed all its tests and is safe. I think it's equally important to make sure that the environment that you're going to be deploying into is also in a healthy state before that release happens. If you imagine you're in the middle of a major incident, you're going to have a bunch of engineers who are working really hard to try and first off understand what the problem is, because until they understand it, they can't possibly resolve it, right? If the code that's running in your production environment changes while they're investigating, all you're doing is muddying the waters and making it harder for them to diagnose. When you make it harder to diagnose, what you're doing is increasing the amount of time it takes to resolve. I'm going to talk quite a bit more about health checks a bit further down the track, but for now, just remember that it is absolutely critical that at the very least you have an environment level health check in place before you even consider going down this route. So that's my definition. Let's put it in context. Hopefully, some or maybe even all of you will be familiar with the content I'm going to go through on this slide. But I think it's important enough to review, so we're going to spend a couple of minutes on it. If you imagine a generic release pipeline, build process, deployment cycle, whatever you want to call it, there are some common tasks which are always going to come through. You're always going to have a developer committing some code. A build is going to follow that. If that build is successful, tests will be run against that. Assuming those tests pass, it's going to be pushed into one or more non-production environments. Further testing will happen, and then finally, it'll be deployed into your production environment. Now, continuous integration is all about the automating the early stage of this. So what you've done is you've hooked up your code repository to your build server, and so when a commit happens, a build will trigger automatically. And then, assuming that build is successful, then tests will run. You can actually take that a lot further. You can take that all the way down to the end, so it's deploying into production, and at that point, it's still only continuous integration. It doesn't become continuous delivery until you're actually aiming to release every single build where those tests in your non-production environments have passed into production. The key word here is aim, right? The difference between continuous delivery and continuous deployment is that you've automated that final step, and every build where those tests pass goes into production. Now, it's important to understand that what we're automating here isn't actually those 6 tasks along the top, right? What we're automating is actually the decisions between the tasks. Automating the activities, you need to get that done before you even consider continuous delivery. Sorry. You could conceivably even have a waterfall release process where you're releasing every 3 to 6 months and have automated all of those steps along the way. With continuous integration, the decision that you're automating is which commits actually get built and then tested. With continuous delivery, you've gotten to the stage where you're fairly reliant on your automated tests, and you've automated the decision of which builds get pushed through into your non-production environment. You're no longer cherry picking, you're pushing everything through. And then finally, with continuous deployment, you've automated that final decision, the decision of when or even if to go live. So, quick show of hands in the room. Who's using continuous integration? Yeah? Okay. Anyone using continuous delivery? Or continuous deployment? That tells you something. That tells you how hard this is to do and how hard it is to get it right. It's not just a problem of automation. It's all about making sure that your whole technology teams are geared up for this process. To get it right, you need to have really good monitoring. You need to have you need to be using test-driven development. You need to be adopting microservices over monoliths. You need the reason that microservices are so important is because you need the applications to be very, very simple. The more complex the application, the harder it is to test. And the harder something is to test, the longer that takes. All of this is about speeding things up so that if you think back to the keynote this morning, Jeremy was talking about disrupting the market, about staying on top of your competition. It's about being able to react and react safely and very, very quickly get to market with whatever changes you need to make. So we've got our definition. As you can see from this slide, there's not a huge jump there between continuous delivery and continuous deployment. So why is it worth taking the risk of automating that final decision if continuous delivery is going to get you most of the way there? And on the face of it, it looks like it does. First off, bear in mind, this isn't something that you actually need to use globally. With any kind of process change like this that you're rolling out, you should be evaluating it on a service-by-service basis. One-size-fits-all solutions are a bit of a myth, right? In reality, you're always going to have edge cases. You've always got situations that are outside of your norm. And if you try to have one solution for everything, what you end up doing is compromising that solution to better fit with those edge cases. So let's have a look at some of the real-world benefits that we've seen from using continuous delivery at AutoTrader. I'd love to show you some continuous deployment benefits, but unfortunately, the year with those figures in hasn't quite finished yet. So maybe next year I'll come back and we'll have some updated slides. So, that's stolen my thunder a little. The transitions aren't working. Okay. In the back end of what we call financial year ending 2016, or FY16 for short, we enabled continuous delivery. And this graph here shows the spike in release volume that followed. Now, you probably can't read, certainly if you're towards the back, you probably can't read the figures on there. But in FY16, we went from almost 2,500 releases to, in FY17, almost 4,500. So we've gone up by 2,000 releases in the space of a year. In reality, it was more overnight than that. Now, the middle graph shows our success rate, which is calculated as a percentage. And again, you can see there that from FY16 to FY17, we've not only gone up, we've not only massively improved as a result of that step in volume, but it's gone up by a much more significant margin than in previous years. The final graph on the right, that actually shows the raw numbers. It shows the total number of failed releases that we had in each of those years. Now, in FY16, we had just shy of 2,500 releases, and we had 49 failures in that, which is already pretty good, right? In FY17, that's 4,366 releases with a total number of failures, 41. Now, a failed release, the way we define a failed release anyway, is one where we've impacted our customers negatively, either internal customers or external customers. It doesn't really matter. So the other great big jump that you can see on that final graph on the right, between FY14 and FY15, there's another story there. I haven't really got time to go into it right now. As I said, there's quite a lot of content here. But if you want to know more about that, either find me in the bar later, or if you check out our engineering blog, which is engineering.autotrader.co.uk, there's a post from me last summer explaining what happened with that jump and what we did to enable it. It's called It Matters What You Measure. So that was all achieved with a mixture of continuous integration and continuous delivery. What are the benefits of going further and going into continuous deployment? Well, to answer that question, what I'm going to do is compare and contrast continuous delivery and continuous deployment. Show you some areas where there's an advantage to using continuous deployment, and some areas where actually it's exactly the same. I'm being brutally honest with this. In some cases, it is absolutely better to just stick with continuous delivery or maybe even continuous integration. Like I said, this is something that you need to evaluate on a service-by-service basis. You need to be thinking about what the maturity of that service. Has TDD been used, test-driven development, from the inception of that service? Are there likely to be gaps in the tests? So, both methods, ultimately, and even continuous integration, right, are about reducing the interval between releases. What happens when you reduce the interval between releases is that you reduce the amount of change that's in each of those releases. The difference between continuous delivery and continuous deployment here is that continuous delivery only really encourages this, whereas continuous deployment, it enforces it by taking that go-live decision out of human hands, right? And making our releases smaller and more frequent is the main driver for that steady improvement that you can see year after year after year. So that's one area where there's a slight difference, right? And what it's doing is it's making it stronger. It's making it more robust, making it safer. Another area where, again, it makes it a little bit stronger, a little bit more robust is around test coverage. With continuous delivery, right, you are encouraging good test coverage. Because when you're aiming to release every build into production, right, every green build, then to stay ahead of that pipeline, you have to be almost reliant on those automated tests. You haven't got the time to do a whole swathe of manual testing, right? With continuous deployment, though, you are completely reliant on it. You're not doing any manual testing at all, apart from maybe locally on the developer's actual machine, right? All the testers are really doing at this point, they're either working in a showcase environment around larger changes, or they're building the test themselves, right? Now, those are two areas where there's a slight difference, just toughening it up a little bit, making it a bit stronger. An area where there's no difference at all, I would say, is the use of feature shields. If you're not familiar with feature shields, these are a really, really powerful tool for making your releases safer, and also to enable you to work on larger changes while still keeping up that regular release cycle. What Feature Shield does is that it allows you to hide your code that's still being worked on behind this shield in your production environment, yet still have it visible, say in a showcase or another non-production environment, so that it can still be tested. Say you're working on a UI overhaul, something like that, right? This is not something that you can achieve in a single build. This is something that's going to take a lot of time to develop. So this is where feature shields are really powerful. And I would say no matter where you are along the journey, even if you're just getting started with CI, you want to look at feature shields. This will make your lives a lot easier, and it will prevent partial code from blocking releases going out. It also gets you out of the need to have multiple branches and merging between them. And if anyone in the room who's ever tried to merge a major branch into the head will know that that is a right pain that you really want to avoid. Another area where there's slight differences is around automation. Now, if you remember when the slide which had the 3 methods on there, I was saying it's not really about automating the activities. It's about automating the decisions. Now, there are, technically speaking, you could do continuous delivery with a manual deployment into your production environment if you really wanted to, right? The problem with that is that, again, you're trying to stay ahead of this dev pipeline, which is going to be moving very, very fast. I mean, some of our more active projects, we will see a new build coming through every 5 minutes. Automation's great. It brings a repeatability. It drastically reduces the chance of human error, both of which bring safety. It also makes it much easier to gather data for reports and audit trails and things like that. And what it tends to do is it tends to speed things up. I said I'd come back to health checks. This is another area where there is a bit of a difference between continuous delivery and continuous deployment. Now, there are 2 kinds of health check that are relevant to what we're discussing today. The environment health check I've already touched on, right? This is the environment healthy? Is it safe to release, right? The other kind of health check that's useful from a deployment point of view are deployment level health checks, application level health checks. So when you've got an automated deployment into a production environment, you don't want to be making any traffic go to that new build until you're sure that A, the application's actually started, B, it started cleanly, and C, that it is actually in a working state. Now, you could achieve that by simply rerunning your automated tests. The thing is, that's quite time consuming, and you've already run all of those tests further down the line, so there is very little value in doing that. It's much better if your application can simply tell you that it started, it's happy, it can get to its database, say it relies on a couple of other services around your architecture, it can get to all of these things. So then your automated deployment can simply just poll your health check page within the application, and when it gets a happy response, then and only then will you make that live, or rather will the script make that live. Now, aside from the benefits for deployment, these application level health checks are really, really useful when you're trying to diagnose an incident, just monitoring in general. So we've built a tool which we're umming and ahhing about open sourcing it one day. It'll require a bit of work. It's quite bespoke to our environment, but it's called Dozer. If you ever see this up for download, what it does is it talks to our load balancers. It finds out about all of the applications that we've got, all of the nodes in those application pools, and it polls them on the health check address. And then it will flag up every single box that has a problem. If you'd gone to the other AutoTrader talk, other AutoTrader UK talk, I should say, I don't think AutoTrader.com are here at the conference today. But if you'd gone to the other AutoTrader UK talk, Dave would definitely be talking about health checks, and he'd definitely be talking about Dozer, because they're a really, really powerful tool. Going back to the environment health checks, like I said, this is asking, is the environment healthy? Is it safe to release? Now, when you're using continuous delivery, that is enough. What we did was on our release dashboard, there's a widget in the top right-hand corner that is hooked into our monitoring, and if even one of our applications goes down, it changes from yes, it's safe to release to ask us. And then if a developer's wanting to release, it says ask, they ping us a message on Slack, and we say, no, it's okay, the problem's actually over here, your application's over here, so it's safe for your release to go out, or not, as the case may be. It's also got another level. So say we're in an MI, or we're doing some maintenance in one of our data centers. We want to hold traffic in the other site, keep it well away from it. We can invoke this, it's not quite a kill switch, but we can invoke this release override, which changes it from an ask to a no, and pops a little message up so everyone knows why we're saying you can't release right now. That's fine for continuous delivery because a human being is actually deciding whether or not you're going live and which builds to go. With continuous deployment, because it's all automated, that isn't good enough. You need something stronger than a health check. You actually need a kill switch. You need it to make sure that the release doesn't even start if the environment isn't healthy. Now, whether or not it will stop any releases that are in progress from happening will depend largely on how you actually release. It'll depend on your architecture. So if you're deploying into static virtual machines, for example, then you probably want to let it continue because say you're halfway through deploying a pool, you don't want to leave it in a state where half the servers have got one version and the other half have got another, because that's just going to make matters worse. But say if you're using cloud, if you're using containers, anything like that, then what you're doing, you're going to be throwing away the servers or containers as each new build comes through. So in that instance, it's actually perfectly safe to stop stuff that's in progress dead, because you haven't diverted any traffic across to it. And it's actually safer to say, no, this release won't go out. It'll go back onto the queue, and once we're happy that the environment's healthy again, then it can go out. Because because you haven't put any traffic on it, it's never gone live. It's not even partially live. All you've done is spin up a few virtual machines which you can just throw away. So, as I said, there are very slight benefits. When you look at it in detail, there's very slight benefits to using continuous deployment over continuous delivery. It's a small step, but an important one. But actually, when you take a step back, instead of looking at the detail and you look at the big picture, the real benefit that you see of removing the human being from the release go, no go decision is that it keeps your product teams honest. It's not hard to imagine a case where you have a product team with a tester who likes to come in early. Like me, I like to come in early. I start at 7:30 in the morning, and I tend to be out the door at 3:30 because I want to get home and have dinner with my family at 5 o'clock, right? On that team, for example, you also have a developer who, say, does the morning school run. And so they're not going to be starting till more like 10 o'clock, and they're probably going to be working till 6 as a result of that. Every morning, that tester's going to come in, and there's going to be a few builds waiting to go. What do you think is going to happen when that tester comes in? Say they see 5 builds waiting to go. Are they going to release each one in sequence, or are they just going to release the last one? They might do a bit of extra testing to make sure that it's all right, but they're just going to release the last one. That's the human thing to do, right? But what they're actually doing by that is they're increasing the risk, because they're taking 5 small releases and making 1 big release. Much more change, much more danger. Ultimately, as I keep on mentioning, both methods are good tools, right? And continuous deployment isn't necessarily going to be better for you. You need to be gearing up across the organization for this, for accelerating everything. And you need to decide which is the appropriate tool for the task at hand on a service-by-service basis. So, I've given you a definition, told you what continuous deployment is. I've told you how that relates to continuous integration and continuous delivery. What about the challenges? Well, the single biggest challenge that you face anytime you're automating a decision like this is fear. Everything else is just another technical problem. The reason that this is the biggest challenge is because it's really hard to trust software to make decisions that you've always left to a human being previously. And no matter how many slides I show you with graphs going up and up and up, it's actually counterintuitive to think that the decision is actually safer left in the hands of a machine than a human being. The best thing that you can do about this one, right, is to build confidence slowly. Don't try and do it all at once, and nail continuous delivery first. Use it as a progressive tool. You can, in fact, one of the things that we're doing as we roll continuous deployment out, we're setting a threshold. And whatever that threshold is will vary from application to application depending on its complexity. But say it's 100 builds. Say 100 builds need to go through where you haven't found anything manually that the automated test didn't also flag up. At that point, you say, okay, well, we've hit our target. We've hit 100 builds where we didn't spot anything. We'll enable continuous deployment, and we'll move forward from there. We'll monitor it. We'll learn from it, right? That's where we're at the moment. So I don't want to give the impression that I've got all the answers and that everything is continuously deployed, because that's far from the case. We've been using it for a few years now, but we've still only got a handful of services that are actually being continuously deployed. The reason from that is because we're taking our time to make sure that we actually understand the implications of this before moving forward. Now, the problem with that is that when you're focusing on the detail, you're taking your eyes away from the big picture. You're running the risk there of introducing technical debt. I'll talk more about this when we get to the cautionary tale at the end. But always keep in the back of your mind, is this going to scale? Will I be able to roll this out wider than I am now? Where am I going to hit a problem? So that's the big one, right? That's the really hard one to get past. Some of the technical challenges. Well, I've got it easy. I work for a classified advertising company. If a release goes wrong at AutoTrader, it's bad, right? It costs us money, potentially. It's certainly going to damage our reputation, because bear in mind, our failed releases, they're customer impacting releases, right? But no one's going to actually die as a result of it. Now, if I was working in the medical sector, or for SpaceX, or a manufacturing giant like Ford, the consequences of failure are much, much greater. They're going to be very expensive, and they might even be life and death. If you're in this kind of industry and you want to continuously deploy, first off, I take my hat off to you, because it's not going to be easy. You need to remember that you're going to have to invest very heavily in your testing. Now, you probably are already investing very heavily in testing if you've got mission-critical infrastructure. I think I once read an article that said that NASA spent something like 10 times the amount that the average US software company did on testing its code, simply because the consequences of failure were so great. And you're going to be in that kind of world if you've got mission-critical infrastructure. Some of the things that you could try is perhaps gain confidence by continuously deploying into a staging environment. Say you've got a production line, maybe hook a dummy production line up to that staging environment so you can learn from it. You're going to take maybe a few years to really understand the implications. But ultimately, you're always going to have to weigh up the cost of all of this. It might simply just be that continuous delivery or even continuous integration is not only more appropriate to your scenario, but also much more cost effective. Like I said, and I will keep on saying, it's much more important to use the right tool for the job than it is to be on the latest and greatest. So what else? Some easier challenges. Well, just as continuous deployment requires that you've got really good test coverage, you also need to have really good monitoring in place before you even consider going there. You need to be able to determine very, very quickly if a release has broken anything. You can't afford to be having a lengthy diagnosis. If not only is your production environment broken, but if you've got a kill switch, as you probably do with a wide variety of apps, then you're blocking releases from going into production. You're building up a backlog of change, and as I said, that is dangerous. That's much more likely to cause a problem than not. If you haven't got a kill switch, you're in an even worse situation, because you're going to be making it harder to actually diagnose what's wrong. One last point on monitoring before I move on. With more frequent releases, you're switching traffic between builds more regularly. And you need this to be seamless for your customers. When you're releasing once every 3 to 6 months, it doesn't really matter if you have a spike in errors at the point in time when the release actually becomes live. Chances are, if you're releasing that infrequently, you're doing it in the middle of the night when no one's watching anyway, right? If you're releasing 10, 20, 30, 50 times a day, it's a whole different story. And at that point, you really can't afford to have a big spike in errors every single time a release goes through. If you've got really good monitoring, that will help you fine-tune that and make sure that you're not making the lives of your customers worse as a result of just simply trying to get stuff out in a more safe and fast fashion. Another challenge is fast rollback. Just because we trust our automated tests enough to enable continuous deployment, that doesn't mean that nothing can get past them. If you think that, you're kidding yourselves. Things can and will go wrong, generally at the worst possible time. And effective release management, at the end of the day, is about minimizing how often that happens. You can never prevent it entirely. We're at, as you saw from the slide with the graphs on, last year we were at 99.06 or something along those lines. This year it's looking like we're going to come out about 99.3%. And we're getting better and better, but we're also very much affected by the law of diminishing returns. We're only going to get smaller improvements the more we improve our processes. We're always still going to have things that just slip through. There are one of the more common ones is generally related to data volumes or traffic volumes in production, which you can't simulate in your non-production environments. Once you've identified that a release is the cause of an incident, you need to be able to roll it back very quickly. But you also need to be able to quarantine the broken code so that you can figure out why it's wrong and get a fix out. One of the things that we're working on at the moment is moving away from using static virtual machines to using containers. We're looking at Kubernetes for this. And one of the big selling points for me as the release manager is that with our new Kubernetes-based solution, it's looking like instead of taking about 6 minutes to roll back an application, it's going to be more like 1. So one of the things that I measure alongside the numbers of releases and how many times we've impacted customers negatively is how long that impact was. Because now we're past 99% in terms of did we break things for customers or not. We're not going to see much improvement there. So what we're going to be targeting instead is how quickly can we recover from that. We accept that we're always going to break things sometimes. Things will always go wrong. So how can we make our customers' lives better? Well, we notice that something's wrong quickly and then get it out. This one is something that will help you get to that point where you've identified which release is the problem quicker. With working out which release is the cause of an incident, the first thing you always look is, okay, which apps have been released? When did the incident start? Try and correlate the two, right? This is standard. The thing is, it's not necessarily, say service A goes down, it's not necessarily a release of service A that's caused that to go down, even if that happened just before. We see this quite a bit. It could be that we've also released one of the underpinning services at about a similar kind of time. And without a change log that shows you what was in both those releases, how are you going to work out which is which? The other benefits of having an automated change log is that you can actually feed this into your release reporting. While as for me as a release manager and for our operations teams, it's probably not that interesting how quickly how long it takes for a story to go from prioritized to deployed to production. But our product teams would say, no, that's really, really useful information. So it's a challenge, but with all of these challenges, there is a benefit if you can master it. As I said at the start of the section, getting past the fear barrier is the hard one, right? Now, if the fear is coming from your technical teams, what that's doing, it's probably highlighting that there's an actual problem that you need to resolve, right? And you should focus on that. If, however, your tech teams are quite happy, but you've still got fear coming from your more analytical layers, your management layers, things, in those situations, right, what you need to do is have a conversation about value. If you can sell the CEO of your company on the idea that smaller, more frequent releases will not only be safer for our customers, but they'll enable us to deliver change quicker and stay ahead of our competition, then you can simply give them a shopping list of all the things that, not just the stuff that I've identified here, every business is different, you'll have your own unique challenges, right? But all the things that you want to put in place to make sure that you can do it safely. So, we've covered the definition, right? We've talked about some of the benefits, some of the challenges, some of the reasons why you might want to go for this. Excluding the likes of Google and Amazon, a lot of the companies who are actually using continuous deployment at the moment are in the startup space. This statement that I've got on the board here is absolute rubbish, right? Or trash, as you'd say over here. It's certainly harder to do in an enterprise, but harder is not the same thing as impossible. So what I'm going to do in this section is I'm going to look at some of the difference between startups and enterprises and how they relate to continuous deployment. The biggest single advantage that startups have is that they're a startup. The reason that that's an advantage for them is because they have no architecture. They don't have 20 years of tech debt, and they won't have defined processes. They probably haven't even thought of the word process at this stage, right? So that means that for them, just simply going, okay, well, continuous deployment is good practice. We should just do this. We'll do TDD and continuous deployment right from day one. They can just do it. You can't do that in an enterprise because you're working under much greater constraints. There's very little you can do about this, right? This is simply the nature of the game. There are, however, other differences where there are things that you can do about it. Startups tend to have a small, close-knit, highly motivated team. Now, I'm not saying that teams and enterprises aren't motivated, because that isn't true. What I'm here highlighting is that instead of having one team of maybe 10, 15 people, you have multiple teams. And when you take a group of people and you divide them into subgroups, what you're doing is you're creating us's and them's. You are creating natural social barriers that have been kicking around in our psyches since the Stone Age. And these barriers really get in the way of our productivity. When you're only one team, if something goes wrong, everyone kind of pulls together. You've got that team spirit keeping you going. The whole company knows each other in a startup. You know, everyone knows their strengths and weaknesses. They know not to bother Jim before he's had his caffeine in the morning, right? All of this makes it a lot easier for startups to solve technical challenges, and continuous deployment is certainly a technical challenge. Enterprises, by definition, have got a much larger headcount. And when you've got this larger headcount, this tends to breed division. And division leads to inter-team politics. And all of that can be quite crippling. One of the things that some of the things that we've done at AutoTrader to try and address this is we've implemented a very flat structure that's made up of a lot of cross-functional teams. This is called the Spotify model, if anyone wants to learn more about that. It wasn't our idea. Obviously, Spotify came up with it, right? The reason that this has helped is because the flatness of the structure removes a lot of the barriers. And the cross-functional teams bring people together to enable collaboration inside the barriers that remain. We've also centralized most of our staff in one physical location. So If I have a problem with one of the applications, if one of them is gone wrong, I'm not firing an email off. I'm not picking up the phone. I'll just get up and walk over to them. We encourage openness, and we work very hard to ensure that we've got no blame culture. All of this combined makes us very nimble for our size. There is a very good story there, which I cannot tell you right now, but if you find me in the bar later and ply me with enough alcohol, I can give you a very good example of exactly how nimble we can be. Another difference between startups and enterprises is that, as a general rule, startups don't tend to be subject to audits, depending on their business model anyway. If you're working in the financial sector, you're going to get audited no matter what. Removing those audits removes a lot of the constraints that we work under. The main problem with audits is that the companies who are carrying them out, they aren't necessarily going to be aware of the latest development practices. You've got to remember that they're not developing the software themselves, or for the most part anyway. They learn about the latest development practices partly through going to conferences, but also partly through auditing companies. If you're at the leading edge, right, chances are you're not going to be catered for. They're working with companies who are at various different stages along the same journey of continuous improvement. And the product that they're selling, the audit itself, has to be relevant to everyone across that spectrum. It's a really hard problem to solve. But it also does tend to mean that the audit tends to be a bit of a one-size-fits-all solution. And if you're towards the leading edge, you're an edge case, you're going to be compromised. And you really do need to be able to pass your audits. Your big customers are going to demand them. Some of them might be regulatory. You might have no choice but to get past them. So this is a really important part of what we do, making sure this works. Now, in reality, I'm probably making this out to be a bigger problem than it is. Generally speaking, you know what the requirements are in advance, right? So what you need to do is simply work out how you can capture all the information that an auditor is going to care about in an automated way. Bake it into your process. You're going to need an audit trail for instant diagnosis anyway. So this shouldn't be too hard to achieve. A good example of this kind of problem is change authorization. No matter how hard you try, you cannot make a non-sentient machine responsible for authorizing a change. That will never fly, right? Perhaps when we have sentient machines, that will be different. But right now, a machine can actually say, yes, all of my conditions have been met, so I'm going to allow this build through. But from a process point of view, they can't be responsible. How I've solved this at Trader is by devolving change powers from myself back to the product teams themselves. Each team has a product owner who's responsible for that product, for the whole life cycle of that product. And one of the things that they do is they prioritize what stories are going to be worked on next. So what I did was define that prioritization was the authorization, which actually makes a lot more sense when you think about it. Why would you authorize a change to go into production after you've spent all the time building all the tests for it, developing the code, and getting it through your pipeline? Surely it makes more sense to decide if a change is going to go ahead or not before all of that work happens. Otherwise, if you decide it's not, you're just throwing all that work away. This final one is a biggie. A lot of startups fail. So no one's particularly surprised when they do. Established businesses are different, and it doesn't matter whether you're a small business, a medium one, or an enterprise. Once you're an established company, you are attracting staff who want stability. When you work for a startup, you know that you're putting your work-life balance on hold. You're taking a huge gamble in the hope that you can build something really special and then sell it for millions or even billions a couple of years down the line, right? If you've chosen to work for an enterprise or even a small or medium business, right, you want a bit of stability. You've maybe got people depending on you, but for whatever reason, you are reliant on that paycheck coming in month after month. If you put out a shiny new release process that reduces the stability of your operation, it's going to cost the company's reputation. It might cost money, and if left unchecked, if you don't do anything about it, it could cost people their jobs. So, is it easier to do in a startup? Yes, it is. absolutely easier to do in a startup. Like I say, you can just do it from day one if you're aware of the tool. But that doesn't mean it's not possible to do in an enterprise. And with the exception of Greenfield, all of those challenges that I've just listed there, all of them can be turned on their head. So startups only have a small team. So when there's a major incident, everyone has to pitch in to work together, which they do, which is great. But if, say, that's a security breach, that might go on for days and days on days. And tired people make mistakes. There's no relief. There's no handover coming. You don't have that in an enterprise. Audits can be a pain. It's certainly not something I look forward to going through, but it's part of the job, and it's an important one because they keep us on the right track. They keep us from getting ahead of ourselves. And as I said, our big customers do tend to demand them. At some point down the line, a successful startup will turn into an established business. At that point, they're going to have to retrofit those audit requirements into their processes. And that's much harder, much more painful than simply doing it up front. In fact, at that point, they probably actually have to define what those processes are. It's not going to be a small thing to do. And then finally, while the stakes are definitely higher in a enterprise, the available resources are much, much greater. If you've got a technical challenge, right, that you don't necessarily have the expertise within the business to overcome, you can bring in a consultant to help you. Startups don't have that option. Ultimately, any situation that you find yourself in life can be viewed in either a negative light or a positive one. There's always pros to balance out the cons. What I try to do is focus on making things better a little bit at a time, instead of worrying overly much about the mountain ahead of me. What you find is when you take that approach, you get to the top of that mountain a lot quicker than you think you would. So, I'm actually running about to schedule, so I don't need to gloss over this final section to give you time to ask questions. Back in 2010, we were rebuilding our main consumer site, and at this point we were right at the beginning of our Agile journey. We'd had one Agile project using Scrum, but we weren't really happy with the way that was done. So we asked for help. We brought in ThoughtWorks just to get us pointing in the right direction. They helped us to introduce continuous integration. In fact, they introduced us to the concept of continuous integration. They also helped us to automate our non-production deployments. The method that we used for this was pretty crude compared to what we do now, but at the time, it was best of breed. The reason that I look back on it and say it's pretty crude is just about the amount of innovation that's happened in this space in the intervening time. You think 7 years in IT is a long time. The method in question relied upon us running CI agents on our production app servers. If anyone in the room isn't familiar with what the CI agent is, it's basically a remote control piece of software. So your CI server will instruct that agent to do certain things. In this case, it'll be instructing the server to stop the app, deploy the new version, and start it back up again. Now, by the time we were ready to actually start deploying the app into the production environment, both ThoughtWorks and the product team wanted us to simply extend our CI pipeline, continuous integration pipeline, straight through into prod. And they wanted to use the exact same method that we were using now for non-production deployments in prod. Now, in principle, that's actually okay. You should always use the same method of deploying in prod and non-prod. Anytime you deploy in a different way to your production environment, you're kind of invalidating some of the testing that happens in non-prod. However, in this case, we weren't happy doing that, and there are a whole host of reasons why. One of the biggest problems was around the agent software. Well, in fact, two of the biggest problems were around the agent software. If you think these are remote control devices, so even if there's no security hole in there, at the very least, it's opening up a potential attack vector. That's not something we were particularly comfortable with in prod. Also, from a licensing point of view, we were actually getting charged per agent. So rolling that out from a few hundred development and test machines out to a few thousand production servers wasn't really going to be scalable. There were also some functional concerns, like because the agents were running on the app servers, there's no integration with our load balancers. There was nothing to say, don't send traffic to the app while I'm doing this. And that would have caused havoc when we actually went live. In reality, we probably could have solved all of these problems. They're all technical challenges. The root of it, though, was that the rest of the org was not ready to have dev staff in control of pushing code out into production. I am, of course, referring to the fear barrier. Ultimately, though, time has actually proven us right on pushing back on this. It forced us to develop a much better solution for automated deployments. Where we went wrong was in allowing it to go as far as it did. We shouldn't have said, yes, it's okay to deploy into non-production this way. We should have said, no, production and non-production should be deployed in the same way, and this method is not robust enough for production. Because we didn't do that, we ended up in almost a standoff between the operations department controlling all the keys and then the development teams who are actually just wanting to get faster and better. The solution that we ended up developing, we not only rolled that out to all of our environments, but we eventually did enable our dev staff to actually decide when something was going to go live. That was the point on the graph when I said we enabled continuous delivery. So, what we learned from this situation? Well, I personally would say that what I've learned from it is that how and why are important questions, and generally speaking, more important than what. In my opinion, why is the more important of the two. If you don't understand the reason why someone wants to do something, chances are you're going to implement it wrong. And for the record, because all the cool kids are doing it is not a compelling reason to do anything. I don't want you to all go back to your offices and say, we saw this talk about continuous deployment, I saw some graphs and it was just looking really, really good, we should do this now. You need to make sure that the organization itself is ready for it. You need to make sure that your services are designed to be ready for it. On the how question, if your implementation is only going to work for a small section of the organization, you need to think again. So in this case, from the license point of view, could we have rolled that out into production? Yes, we could have. That would have added 50 odd, maybe 60 servers at the time to our license, but that wouldn't have been a huge amount. But there's absolutely no way that we could have scaled that out to the 2,000 servers per data center that we were running at the time. You're also, well, at least supposed to be on a journey of continuous improvement. So you need to make sure that you're not making anything worse, right? The lack of integration with the load balancers, if we just let that go, when a new release went out, you would get errors every single time a server went down. And if you remember what I keep on harping on about one-size-fits-all solutions being a myth, it's true, but that doesn't make the one-size-fits-all any less desirable. It's just easier to manage that way. What I try to do is aim for it, but accept that I'm never going to get there. Accept that there will always be edge cases. And I understand that rules are defined by their exceptions. I stay flexible where I need to, but I don't have two ways of doing something when I don't have to. So that was 2010. The world of Trader has moved on away since then. In fact, that much better solution I've just been telling you about, we rolled that out to 250 odd apps, which is all but maybe 3, I think. And then we deprecated it at the beginning of last year. We've replaced it with a service that we built ourselves, which is provisioning cloud environments. That's been in development for a few years. That's been continuously deployed since mid-2016 without issue. It's been geared around running a private cloud, a cloud stack instance in each of our data centers. But we're now finding that that's limiting to us. So as I mentioned earlier, we're now pivoting away from that, but using the same cloud provisioning service to control Kubernetes in Google Cloud. Continuous delivery is the standard that we use for most of our applications, although there are a few legacy systems that are still using continuous integration. They will never move past continuous integration. These are monoliths. These are things that we need to kill if we want to move forward. Continuous deployment is still in the trial phase while we work out all the kinks, but it's working well for us so far. There's still a bit of work to do before I'd be comfortable actually using this more globally. But I'm pretty confident that by this time next year, we'll have a few consumer-facing services that are being continuously deployed. We're actually, in the last couple of weeks, we've taken some steps to having our first consumer-facing service continuously deployed. And I think by April, that will be, every single build will be going out, assuming certain conditions are met. So, final slide, it's okay. Hopefully, you all understand continuous deployment, what it is, and how it relates to CI and continuous delivery. I've done my best to explain the benefits and the challenges, although it's worth remembering that, as I said, every business is different. You're always going to have your own unique scenarios, your own unique challenges to face. And our understanding of these is still growing. We're still in the early days. It's only been a couple of years since we pulled the trigger on the first service to be continuously deployed. And it will be at least another 2 years before we have the bulk of our services continuously deployed. And then finally, I told you a cautionary tale about the early days of our Agile journey, and I explained why we didn't simply implement the first solution we came across. If there's one thing I'd like you to take away from this talk, it's this. Continuous improvement is a journey, and each step along the way will reveal something new on the horizon. In a nutshell, what I'm saying is that anything can be improved upon, and any challenge can be overcome. Thank you for your time.